I'm even more pleased that this year we see more and more product designer people, way more than engineers that we usually engage with. Designers understand more and more that 3D printing can help them to accelerate time to market, make their companies more competitive, and save money on their daily prototyping work. And each one of the product designers that sits here in this room tomorrow is going to be our ambassador, helping us as a market leader to embrace 3D printing and transform traditional manufacturing into 3D printing market. So those designers helping us to shift from 2D in towards what we call the 3D, or design for additive. Design for additive is the things that makes companies more competitive and faster with more agility. So my presentation today is going to touch base with the market trends, and I'm going to give you a bit of sense of what accelerate the market, so you will have a bit understanding of what's behind this industry that makes this industry move so fast. And I'm going to also help you to understand how 3D printing can be a good fit into your strategy and make your companies much more competitive. So with that said, I'll start with some numbers. I don't know if how many of you knows, but 3D printing is the #1 fastest growing industry that we have today on the globe. It's faster than IT, it's faster than telco, it's even faster than cyber. So the numbers, it took us like 20 years to get into the $1 billion industry, and now every year the industry is growing multi-billion dollar. Right now we're standing around $7 billion. This is the size of the industry. $5.5 billion comes from plastic, $1.5 billion comes from metal, and we expect the industry to grow towards $11.5 billion within the next 2 years. So this industry is moving very fast, and it's a very good place to be in as a growing industry. Now, if you think about what's the drivers that accelerate the markets, I would say there's three accelerators, three catalysts that push this industry fast. The first one, and by far, is that additive manufacturing today is much more affordable than it used to be in the past. With the varieties of professional printer, low cost, the adoption is getting higher. The second catalyst behind pushing that industry forward would be what we call the application matureness, or we're saying design realism. You will hear that term, design realism. With the varieties of materials, with the color accuracy, as you can see here, certified by Pantone, today you can take the design to the edge and bring it into that level of part realism. With that accuracy of prototyping in a great smooth surface in different colors, as you can see here on the slide behind me, and of course with a multi-materials and multi-textures. Everything comes from a single platform that provides you this utmost experience, what we call design realism, and everything can be printed with super clear materials, and this is the level that each one of us here in this room should shoot at. And the third part of accelerating the market, I would say, if I mentioned the fact that additive manufacturing is cheaper, I said the part realism now is on the edge, and the third piece is, of course, the end-use part adoption that we mainly see from aerospace and automotive for low-volume production and tooling application. So let's see some example. Here's an interesting case that I brought you today. This is about Mini Cooper. This is about BMW project. I'll give you a big background. So BMW in China wanted to differentiate themselves versus other OEM. So they decided that they're going to give their customers the option to go online by themselves and design their side lamps, as you can see here in the yellow part. So each one of their customers can go online, sit down with his kits, draw some draws, prepare their side lamps, and then click on the internet, and we will print them the parts, and they will assemble it into their car. These are the results that you probably will see from a Mini Cooper, and we have thousands of parts right now, cars driving in China, with side lamps produced by 3D printing. And the next project that we have is going backward into the fuel cap. Now we're working on the fuel cap, and it's very cool. It's under the trend that we see in the world called quantities of one, where customers and manufacturers can customize product per customer. And that helps them to eliminate stock and inventory and print it directly to each one of the customers. So we're very proud of this project. This is one example for low volume. We're talking about thousands of units every year produced by 3D printing into cars. Here's more examples. Siemens. Everybody knows Siemens Mobility. They have thousands of trams driving all days in Europe from point to point. But unfortunately, these trams are getting into accidents. There's car accidents. They're bumping each other. The stats, by the way, just FYI for you to know, the stat talks about every 2 weeks car accidents with trams in Europe. So every time when it happens, they stop the tram for almost 2 weeks. And they ship the bumper here from their logistics hubs. So Siemens took a strategic decision, and they bought Stratasys, FDM, Photos 900 platforms, and they spread them all across Europe. And by that, one, they eliminate stock, so you don't need any stock anymore. And they print the bumpers in 3D printers and just assemble it, and it takes 48 hours to bring back the tram. So this is a very good case study for a company that practically leverage 3D printing for low volume production and now switching into the tooling applications. Obviously, the whole driver behind toolings is to make jigs and fixtures lighter. So instead of having a metal one, you have 3D printing. It's also help you to your shop floor team to be more productive, because you can create special geometries that helps the team to move faster. What you see here is a classic, what we call sacrificing tool. So you print the part in 3D printing, and then you wrap it up with, in this case, with carbon fiber, and then you pull out the parts. You get the special geometries made of carbon fiber for jigs and fixtures. A very good case study would be here, probably this company, Eckhart. Eckhart is, for those who don't know, it's a U.S. industrial solution provider working with the big manufacturers. You can see the names here at the bottom: Boeing, GE, John Deere's, and others, providing them robotics and shop floor toolings and jigs. So to sum up my part, 3 catalysts that pushing the market at a cheaper price, design realism, and of course end user part for low volume productions and jigs and fixtures. We are in a transition, moving from a company with 2 technologies, PolyJet and FDM, which covers mainly prototyping for design and concept verification and functional design and low volume production. And now we're expanding towards SLA, HSS, and LPM for metal, and covering the whole spectrum of 3D printing, from prototyping all the way to manufacturing, and of course healthcare applications, both for shared office, for product designers, but also for engineering who wants to do functional design, for toolings and low volume productions, and in the dental, focusing on 2 areas, in the healthcare, focusing on 2 areas, dental and what we call anatomical modeling, which is mainly for surgeries, preparations, and training, and so forth. So this is our value proposition for 2020. It's going to be a very exciting year, a lot of cool stuff, and looking forward to come up and meet you guys. And that's summarizing 30 years of experience in an industry with many awards and more than 1,000 patents that we have as a company. We have more than 140,000 installations, more than 20,000 customers. But most important, I think, to my opinion, is that we have a very, very solid network of partners, a very strong sales team, and application engineering with a wide install base here in Korea. I believe we have the best partner network. In person, thank you very much.